Imagine a time before time, a place before places, a universe just beginning to take shape. In this early era of the cosmos, there was no Earth, no sun, no galaxies as we know them today. Instead, the universe was filled with a swirling, nebulous fog of dust and gas. Picture vast cosmic clouds stretching across the unfathomable expanse of space, their particles dancing in the primordial darkness. What we're talking about here is the birthplace of planets. This is where it all starts, in a protoplanetary disk. Now that's a bit of a mouthful, isn't it? But it's actually quite simple. Picture a spinning mass of matter, almost like a cosmic whirlpool. This whirling, twirling disk of dust and gas is the starting point of a planet's life. You see, the universe is a bit like a cosmic bakery. And in this bakery, the main ingredient for making planets is the dust and gas in these protoplanetary disks. These particles, no larger than a grain of sand, started to stick together. They coalesced, forming larger and larger clumps. These clumps, over millions of years, grew, eventually becoming planetesimals, the building blocks of planets. And the force that made this all possible? That's gravity. Gravity was the cosmic baker, kneading together the ingredients, shaping and forming the planetesimals. Without gravity, all the dust and gas would have simply drifted apart, never forming anything larger than a tiny speck. Let's take a moment to appreciate the magnificence of this process. From a simple cloud of dust and gas to the birth of planetesimals, all driven by the power of gravity. From these humble beginnings, the grandeur of the cosmos took shape. The seeds of planets were sown, setting the stage for the incredible journey of planetary formation. From this cosmic soup, the seeds of planets began to emerge, setting the stage for an incredible journey. Gravity, the invisible force that keeps our feet on the ground, played a starring role in this cosmic drama. This enigmatic power, seemingly delicate enough to let us jump, yet strong enough to anchor us to Earth, was the master puppeteer in the early universe's grand theater. Imagine the universe as a colossal stage filled with scattered clouds of dust and gas. Now, picture gravity as an unseen artist, subtly guiding and pulling these particles together. It's akin to the way a static charge balloon attracts tiny dust particles in your living room. Gravity, in its cosmic scale, began to gather these cosmic dust and gas particles, drawing them together. These particles, once solitary, began to cluster, forming larger and larger agglomerations. The more mass these clusters accumulated, the stronger their gravitational pull became, attracting even more matter. This process was self-reinforcing, with gravity continually amplifying the clump's growth. These growing clumps of matter were the seeds of future planets. They were the embryonic beginnings, the cosmic cradle of what would one day become a diverse family of celestial bodies. From the gas giants like Jupiter and Saturn to the rocky bodies like our own Earth, each began as a humble seed nurtured by the power of gravity. In this cosmic nursery, gravity was the gentle yet persistent force, coaxing and nudging, pulling and gathering. It was the silent maestro conducting an orchestra of dust and gas, crafting symphonies of celestial bodies in the vast concert hall of the universe. It was the hidden hand, shaping and molding, directing the dance of particles in the cosmic ballet of planetary formation. This process, this incredible journey, was not a quick one. It took millions, even billions of years. The universe was not built in a day, and neither were the planets. But through the persistent power of gravity, these early seeds of matter grew, evolved, and transformed into the planets we recognize today. Just like that, gravity set the stage for the next act in our cosmic story: planetary growth. The seeds of planets, now drawn together, were about to embark on a growth spurt of cosmic proportions. Imagine a snowflake in the midst of a blizzard. As more snowflakes collide with it, they stick together, gradually transforming the solitary snowflake into a sizable snowball. This is accretion, a fundamental process in the formation of planets. In the early universe, the seeds of planets were nothing more than tiny pieces of dust and gas, swirling around in the vast cosmic soup. But as these seeds started to grow, a fascinating thing happened. They began to draw other particles towards them, their gravitational pull strengthening with every new addition. This collection of matter is what we call an accretion disk. As the seeds within the accretion disk collided with other particles, they didn't just grow in size, they also grew in heat. The energy of each collision converted into heat, resulting in the formation of a molten core. This is the heart of a planet, the engine that would drive its many processes. But accretion is not a gentle process. Picture the chaos of particles smashing into each other at breakneck speeds, the cataclysmic collisions, the explosive energy releases. Yet, from this chaos, order gradually emerged. Each collision, each merger brought the seeds one step closer to becoming fully fledged planets. This process, however, didn't happen overnight. It took millions of years for these seeds to grow into the size of a planet. And as they grew, their gravitational pull increased, drawing in more and more particles, causing them to grow even larger. It's a snowball effect of cosmic proportions. Over time, the relentless process of accretion would eventually slow down. The remaining particles in the accretion disk would be swept up by the growing planet or pushed away by its gravitational force. And what's left? A newly formed planet, a cosmic marvel born from the dust of the universe. With each collision, these growing bodies were on their way to becoming fully fledged planets. Not all planets are created equal. In fact, our universe is a veritable smorgasbord of planetary diversity. As we journey through the cosmos, we encounter a myriad of planets, each with its own unique characteristics and formation story. Let's take a closer look at this celestial ensemble. First, we have the gas giants, colossal worlds primarily composed of hydrogen and helium. Jupiter and Saturn, the behemoths of our solar system, are stellar examples of this category. These are planets that dwarf the Earth, their vast atmospheres swirling with turbulent storms and their cores, a mystery that continues to baffle scientists. A notch smaller than the gas giants are the ice giants. Neptune and Uranus fall into this category. These planets have a similar gaseous makeup, but with a higher proportion of ices made from water, ammonia, and methane. Their enchanting blue hues are a testament to the rich and complex atmospheres these planets possess. Then we have the terrestrial or rocky planets like our home, Earth, along with Mercury, Venus, and Mars. These planets have a solid surface, with mountains, valleys, and canyons. They're made mostly of silicate rocks or metals, with a molten heavy metal core, mantle, and crust. In between these categories, we find a plethora of other types. Take, for instance, dwarf planets like Pluto, with its heart-shaped glacier, or the thousands of exoplanets that have been discovered in the Goldilocks zone, where conditions might just be right for life. Each planet, regardless of its type, is a world unto itself, with its own unique environment, weather patterns, and potential for life. They are a testament to the incredible diversity of our universe, each one formed from the same cosmic dust, yet each so different. The variety is truly astounding, and it's a thrilling reminder that our universe is far from uniform. It's a cosmic kaleidoscope of planetary diversity, where each world offers a new perspective, a new landscape, and perhaps new possibilities. From gas giants to rocky worlds, our universe is teeming with a rich variety of planets. But what about beyond our solar system? Could similar processes be creating planets around other stars? Let's delve into the realm of the unknown and explore the tantalizing possibility of exoplanets. These celestial bodies, much like our own home planet, could be taking shape right now, in far-flung corners of the cosmos, around stars light years away from us. Just imagine trillions of miles away, a star not unlike our sun, with its own swirling disk of dust and gas. The cosmic dance of gravity is at play, pulling together particles, creating the seeds of what might one day become a new world. Take, for instance, the discovery of Proxima Centauri b, an exoplanet located in the habitable zone of the star Proxima Centauri, the closest star to our sun. This celestial body, roughly the same size as Earth, orbits its star in just 11 days. This discovery has sparked an explosion of wonder and curiosity. Could there be life on Proxima Centauri b? What kind of life might it be? Or consider TRAPPIST-1d, another exoplanet, part of a system of 7 planets orbiting the ultra-cool dwarf star TRAPPIST-1. This planetary system is intriguing because its planets are similar in size to Earth and Venus, and 3 of them, including TRAPPIST-1d, are in the habitable zone of their star. These discoveries remind us that our universe is a cosmic marvel, a testament to the power of gravity and the endless possibilities of cosmic evolution. They challenge us to expand our understanding, to push the boundaries of what we know and venture into the unknown. Every exoplanet we discover brings us one step closer to answering some of the most profound questions of our existence. Are we alone in the universe? Could there be other worlds just like ours? Just as our universe was born from dust and gas, so too could countless other worlds be forming around distant stars. This is the incredible journey we are on, exploring the grandeur of the cosmos, and every discovery is another piece of the puzzle, another step on this cosmic journey.